Okay, so we've already talked about the first two definitions for oxidation and reduction. The first one was in terms of oxygen transfer. The second one was in terms of electron transfer. Now the third one we want to talk about is in terms of oxidation number. Oxidation number. Now, oxidation is a reaction that proceeds with an increase in oxidation number of relevant species. So in oxidation, the oxidation number of relevant species increases, it goes up. Reduction is a reaction that proceeds with a decrease in oxidation number of relevant species. In reduction, the oxidation number of the relevant species decreases. Now, what is oxidation number? Remember SHS 1. We learned that oxidation number is the real or the hypothetical charge an atom carries, whether it is alone or it is in a chemical substance. And this is based on some laid down rules. What are those rules? Let's go and refresh our minds and our memories on those rules. So the rules for assigning oxidation numbers. Now the rule number one, if you see any element on its own, uncombined with any other different element, its oxidation number is 0. For example, if you see sodium alone, its oxidation number is 0. If you see chlorine gas, Cl2 alone, now Cl has not been combined with any other element, so its oxidation number is 0. Second rule, if you have a simple ion is a charged atom. For example, aluminium 3+. It's just an atom which is charged, so it is called a simple ion. Its oxidation number is equal to the charge carried by that ion. So in the case of aluminium ion, its oxidation number is equal to +3. Group 1A elements: lithium, sodium, potassium, rubidium, cesium, and francium. If you see them in any chemical substance, their oxidation number over there is +1. When you see them in any chemical substance, their oxidation number is +1. Which means when they are alone, they are not in any chemical substance, so their oxidation number will be 0. Good. For group 2A elements, beryllium, magnesium, calcium, strontium, barium, and radium. Whenever you see them in any chemical substance, any chemical compound, or any complex ion, their oxidation number over there is +2. It's constant, just like the group 1A elements, which is +1, also a constant. Now, halogens, the fluorine, the chlorine, the bromine, the iodine, they are called the halogens. When you see them in a chemical compound or any chemical substance, their oxidation number is usually -1. At times it can change, but hey, we are not interested in that one for now. For now, it is usually -1. Hydrogen, element number 1. When you see hydrogen combining with non-metals, hydrogen will have oxidation number of +1. However, if hydrogen is combined with metals, its oxidation number will be -1. So hydrogen with non-metals +1, with metals -1. Let's keep that one in mind. Now, oxygen. usually in its compounds or in its chemical substances, oxygen has an oxidation number of -2. The exception is when it is found in peroxides. An example of a peroxide is hydrogen peroxide. Now, in peroxides, oxygen has an oxidation number of -1, not the usual -2. Let's keep that one in mind. Now, if you have a compound, the sum of the oxidation numbers of the individual atoms in a chemical compound is equal to 0. So if you have a compound like sodium hydroxide, when we take the oxidation number of sodium, oxidation number of oxygen, oxidation number of hydrogen, and we add them together, we are going to get 0. That is what we are trying to say. Now, last but not the least, the sum of the oxidation numbers of the individual atoms in a complex ion is equal to the charge carried by that complex ion. Well, what is a complex ion? We've talked about a simple ion, a charged atom. Now, a complex ion is a charged group of atoms. For example, you can have sulfur and 4 atoms of oxygen coming together to form the sulfate ion. Now, it's an ion because it has a -2 charge, but it is made up of more than 1 atoms. So we call that one a complex ion. Now, what we are saying is, if we take the oxidation number for sulfur and that for the 4 oxygen atoms and we add them together, we are supposed to get -2. These are the basic rules for assigning oxidation numbers that we need to be aware of if we will be able to find which species is being oxidized and which one is being reduced based on oxidation numbers. So you can take your time and go through the rules once again, then follow me to go and solve questions using these rules for assigning oxidation numbers. Now we have examples here. Whenever you are given any chemical reaction and you are asked to find which species or which substance is undergoing oxidation and which one is undergoing reduction, what you need to do is to write down the oxidation numbers of all the atoms or all the elements present in that chemical equation. Now, after writing them down, you can compare and see which one is undergoing an increase and which one is undergoing a decrease. The one undergoing an increase will be the one undergoing oxidation, and the one undergoing a decrease will be the one undergoing reduction. Let's look at the first example. Now, in the first example, we have 2 moles of iron 3 ion combining with 1 mole of tin 2 ion to produce 2 moles of iron 2 ion and a mole of tin 4 ion. So we need to look out for the oxidation numbers for the individual elements over there. So the first one. Now remember, we said every simple ion has its oxidation number being equal to the charge of that what? Ion. Now all these ions over here are simple ions. That makes our job very easy, huh? So the oxidation number for ion 3 will be +3, the charge carried by the what? The ion. This one too is a simple ion. Its oxidation number will be +2. That one is a simple ion, +2. A simple ion, +4. Very easy. Now let's compare. Now we are going to compare the ions in the chemical equation, and we will compare the tin in the chemical equation. Now you can see that with the ion, its oxidation number has decreased from +3 to positive 2. So there is a decrease in oxidation number. And what did we say about decrease in oxidation number? We call that one reduction. So ion 3 plus is undergoing reduction. Let's look at the tin. We had tin 2 plus, later forming tin 4 plus. So its oxidation number has increased from positive 2 to positive 4. And since there's an increase in oxidation number, we are saying tin is now undergoing oxidation. So we can say that tin 2 has been oxidized and ion 3 has been reduced. Now it makes sense, reduced because the oxidation number has reduced from positive 3 to positive 2. So there's a reduction in oxidation number. So it's the same as the kind of reaction it is undergoing, which is known as reduction. Let's look at the next example. In the next example, we have a complex ion, a complex ion, a simple ion, a simple ion, a compound, a compound. We need to calculate the oxidation number of each available species over there. So let's go. Now, we all know oxygen is -2. And we have 4 of the oxygen. 4. So -2, -2, -2, -2. That is -2 times 4. And that will give us -8. And the manganese, we don't know, so we represent it with the letter X. But when we add the oxidation number of manganese, which is X, to that of all the oxygen atoms, which is -8, we are supposed to get the charge of the complex ion. And the charge of the complex ion is -1. So our X becomes equal to +7. So the charge for manganese over here will become +7. +7 for the manganese. Now let's go to the next one. That one too is a complex ion. So the oxidation number for the 2 carbon atoms and the 4 oxygen atoms, when we combine them, we are supposed to get this charge carried by the whole complex ion, which is -2. So we don't know the charge of carbon, but we know from here that oxygen is usually -2. So -2 for oxygen. And how many oxygen atoms do we have there? 4. So -2 times 4. That gives us -8. We don't know the oxidation number for carbon, so we represent it with X. But how many carbon atoms do we have there? We have 2. So it becomes X times 2. That will give us 2X. So the 2X plus the -8 should give us the total charge carried by this whole complex ion, which is -2. Now we have 2X is equal to -2 plus 8, which will give us +6. So our X will be equal to +3. So the charge for carbon is +3, and that for oxygen is -2. You see how we are applying the rules for assigning oxidation numbers? You get there, don't worry. Now for the hydrogen ion, it's a simple ion. And we are saying for simple ions, their oxidation number is equal to the charge of that simple ion. And its charge is +1. So its charge becomes +1. We are done with the reactant side. Let's move to the product side. Now we have manganese, 2 ions. That one is a simple ion, so its oxidation number becomes +2. That is the charge carried by the ion. We have CO2. We know oxygen to have oxidation number of -2, but carbon. So X plus, now we have 2 atoms of oxygen, so -2 times 2. So we have X plus -4 equal to, now this is a compound. So So the sum of the oxidation number of carbon and oxygen is supposed to give us 0. So our X becomes positive 4. So the charge for carbon becomes positive 4. Then we have in water. We said hydrogen when it meets a non-metal. Now remember, oxygen is a non-metal. So hydrogen will have a charge of positive 1. And we are saying oxygen, apart from in peroxides, its oxidation number is usually negative 2. So this is definitely not a peroxide. So the oxidation number for oxygen over here will be negative 2. Now, let's compare the oxidation numbers and see what is happening. Now, manganese was positive 7 here. It is now positive 2 over there. That means the oxidation number of manganese is decreasing from positive 7 to positive 2. And when it decreases, we say it is undergoing reduction. For the oxygen, it's negative 2 here, negative 2 over there, and negative 2 over there. So oxygen is not experiencing any changes in oxidation number. So from our definition, oxygen is not our relevant species. That is why its oxidation number is not changing. So we leave that one. So manganese over here is being reduced from positive 7 to positive 2. Now let's look at this substance here, C2O4. Now over there, carbon has a charge of positive 3. But at the product side, its oxidation number increases to positive 4. So there's a change in its oxidation number from positive 3 to positive 4. And that is an increase. So carbon over here is undergoing oxidation. But the oxygen is negative 2 over here, negative 2 over there, negative over there. So oxygen is not undergoing any changes in oxidation states. Hydrogen ions over here has a charge of positive 1, and over there hydrogen still has a charge of positive 1. So that one too is not undergoing any changes at all. So we can say for sure manganese over here in MnO4 is being reduced from positive 7 to positive 2, and it is undergoing reduction. Carbon in C2O4 is increasing in oxidation number from positive 3 to positive 4 in CO2. So the carbon is undergoing oxidation. Good. So with these two ideas in mind, try and see if you can work out which species is undergoing oxidation and which one is undergoing reduction in examples 3 and 4. Okay, so in example 3, we all know oxygen has a charge of negative 2, right? And this is a complex ion. So the total charge of oxygen will be negative 2 times 3. That will give us negative 6. We don't know the charge of iodine over here. So X plus negative 6 is equal to negative 1. So X is equal to positive 5. So iodine has a charge of positive 5 over here. Now, iodide ion is a simple ion. So its oxidation number is equal to its charge, which is negative 1. Over here we have iodine standing there alone in an uncombined state. It is not combined to any other different element. And it is also not charged. So its oxidation number becomes 0 according to the first rule. Then with water, we know hydrogen positive 1, oxygen negative 2. Now you realize we don't have hydrogen over here, right? Which means this equation is not balanced there. But we are not going to worry about balancing this equation for now. But we want to see which species is undergoing oxidation and which one is undergoing reduction. That is what is important to us for now. Okay, so iodine from positive 5 to 0. is showing a decrease in oxidation number. So it's undergoing reduction. Then the iodide ion is showing an increase in oxidation number from -1 to 0. So it's undergoing oxidation. For the oxygen, it's -2 over here and it is -2 over there. So it is not a relevant species. Let's look at the last example. In the last example, we have iron metal. It is an element on its own, not combined to any other element, and it is not charged to. So its oxidation number from the first rule is 0. Copper 2 ions. It's a simple ion, so its oxidation number is equal to its charge, which is +2. Ion 2 is also a simple ion, so its charge will be +2, and copper is alone, its oxidation number will be 0. So when we look at them critically, you realize iron has oxidation number changing from 0 to +2, and it's undergoing oxidation because its oxidation number is increasing. Copper reducing from +2 to 0, so it's undergoing a reduction in oxidation numbers. Thank you.